Okay, good morning, good afternoon, and good evening to everyone. Today's tutorial, I'm going to focus on a topic which is known as the random variables and their distributive probability distributions. So we're talking about random variables, and their probability distributions. That's our focus for today. So now I want us to understand that even as we are looking at probability, we've talked about a number of things under probability. We defined what probability is. We defined how to assign these probabilities. Those methods we're talking about the relative approach and the other types of probability assumptions on how we're able to assign these probabilities. And then we talked about some of the rules to follow when it comes to assigning probabilities, and I believe you've gone through all those tutorial videos and you've basically gone through a number of rules concerning probabilities. But to today, we're simply talking about random variables and their probability distributions. So we have to understand what a random variable is, and we have to understand what kind of probability distributions are we going to be talking about in this lesson. So I'll start first of all by defining what is a random variable. So once we understand the definition of a random variable, even where we'll be going, at least we will not have difficulties. So the first thing, or the first concept we're supposed to understand, is the definition of a random variable, because we'll be dealing with a random variable throughout this lesson. What is a random variable? So we have to understand, the same way we've been talking about variables in mathematics, this is what we're talking about now in probabilities. So when it comes to a random variable, we're just talking about is a numerical measure. What is a random variable? We're just talking about it being a numerical quantity. A numerical quantity whose value is determined by chance. I'm sure something needs to click within your mind when you talk about determined by chance. So we're talking about a random variable is basically a numerical quantity whose value is determined by chance. So by chance, what do I mean? Whose specific value cannot be predicted with certainty before experiment. So we're just talking about something whose value cannot be predicted with certainty before experiment. So that's basically a numerical value. We're just trying to assign some numerical quantities to this random variable, to this variable. So basically, if I talk about a random variable, just talking about it being a numerical outcome of a random process. Another definition we can talk about is just basically a numerical outcome. A numerical outcome of a random process. A numerical outcome of a random process. That's basically a random variable. So what are we simply talking about? These random variables, we're just being told that if we're basically conducting a certain experiment, and on that experiment we're talking about numerical quantities which you can predict based from experiments, those numerical quantities are able to be represented by any certain random variable, as long as this variable represents some specific quantities which is coming from an experiment, then it qualifies to be called a random variable. So what am I simply saying here? We're simply saying that this random variable is just basically it assigns numbers to each possible outcome of the experiment. So maybe I can just write this point to say it assigns it assigns numbers. It assigns numbers to each possible outcome. To each possible outcomes. I know I've understood and we've simply talked about a lot of outcomes and the probabilities. So basically, maybe if I'm talking about maybe a sample space, having a total number of possible outcomes, maybe if those possible outcomes, we can just simply refer to those possible outcomes to be in terms of numerical values. So the x can take up numbers to each possible outcomes of those elements in the sample space. So when it comes to those random variables, we're simply saying that a random variable or random variables are represented by uppercases. By uppercases, I mean capital letters. We can speak capital letter X, capital letter Y, capital letter Z, etc. So we're talking about random variables, or representing random variables by uppercases or capital letters, and its particular values will be represented by lower cases. So this is a brief description of what a random variable is. So now, when it comes to you understanding what a random variable is, you are supposed to understand again the types of random variables. This is just basically the definition of a random variable. I'm simply saying it is a numerical quantity whose value is determined by chance. A numerical outcome of a random process, or maybe we're simply saying this is just basically a variable which assigns numbers to each possible outcomes. So once you understand that this random variable is being represented by uppercases X, Y, Z, never represent a random variable by a small letter. Small letters are just basically representing the values which are assigned to the random variable, but the random variable itself should be able to take up capital letters. Now, I want us to talk about the types of random variables. So we've understood the definition of a random variable. Now we're talking about the types of these random variables. So what are we simply talking about under random variables? We're simply saying that these random variables we're talking about, a random variable can be discrete or continuous. So basically, when it comes to types of random variables, we are having an interpretation to say a random variable can be discrete, or it can be continuous. A random variable can be discrete or it can be continuous. A random variable can be discrete or it can be continuous. So now what do we mean when we say a random variable is discrete? What do we mean when we say a random variable is discrete random variable? So when it comes to a discrete random variable, we're simply saying that this is a random variable that takes up countable numbers. So if a random variable is discrete, we're simply saying that the random variable takes up countable numbers. That's the understanding you're supposed to be able to have there. In other language, you can just simply say that this one takes up integer values. Takes up integer values. I'm sure we're able to understand from mathematics or the sets of numbers where when it comes to integers, what are integers? Basically, integers are simply saying that these are counting numbers basically. Yeah, so when it comes to discrete, we're just talking about countable values. So are you able to count those values? That's the discrete case. So some of the examples you can look at maybe when it comes to discrete random variables, examples might include, maybe if you are trying to look at the attendance from a statistics class. So maybe if I was to look at how regularly you tend to come for class, or maybe how is your attendance, so your attendance can be counted. Sometimes we can talk about the number of bids won by a building constructor. So if you look at maybe the number of bids won by a building constructor, there's a possibility that a contractor can have the following wins. Can win maybe 0 contracts. There's a possibility that the contractor can win 1 contract. There's a possibility that the contractor can win 2 contracts. There's a possibility that the contractor can win 3 contracts, 4 contracts, etc., etc. So these values here can be assigned to a random variable. No wonder I'm simply saying that when the random variable is discrete, we're talking about countable numbers. There's a situation where we're talking about attendance in a statistics class. You attending a class, your attendance can be counted. Attendance is a possibility that you never came, the whole month you never came for any statistics class. It means that your attendance was 0. There's a possibility that the whole month you just came once. There's a possibility that the whole month you just came twice. There's a possibility that the whole month you just came 3 times. Or there's a possibility that the whole month maybe you came 30 times. Maybe if you're talking about 30 days in a month and statistics is always every day, there's that possibility. So these values here which we're talking about here are the ones we are regarding to be countable numbers. So the countable numbers here are assigned to a random variable. This random variable maybe can be x, which is a capital letter, or maybe it can be y, or which it can be z. We're simply saying that assigning, or maybe random variable should be represented by capital letters. So x can be a random variable which takes up values maybe 0, 1, 2, 3, way up to a 30 when I'm talking about the attendance of a statistics class. Or maybe I can simply say that the random variable x takes up values 0, 1, 2, 3, 4 when it comes to a contractor, bids won by a contractor. So all those cases are simply talking about the discrete random variables. We're simply saying that under discrete random variables, all the variables in this case, they are just taking up countable numbers. What about in a situation whereby when it comes to a continuous case? Remember, discrete talking about variable, the random variable taking up countable numbers. But what about in a situation whereby we're talking about this random variable being continuous? So if a random variable is being continuous, we're simply saying that it can assume an infinite number of values within a given interval. This is a situation whereby a random variable assumes an infinite number of values within a given interval. So what does this mean? I can give a certain interval maybe from 0, e.g. there's a case whereby this random variable can assume infinite number of values within any given interval. E.g., let's say the given interval is 0, or maybe the interval we're talking about is 0 less than x and x is less than 10. So this interval here, there are a lot of numbers which this x can assume. There are a lot of numbers which this x can assume. For example, x can take up maybe 0.1, x can take up maybe 0.2, x can take up maybe 0.3, x can take up maybe 0.4. It continues, x can take up maybe 0.9, x can take up maybe 0.912, x can take up maybe 9.9999. As long as those values are being taken up or are being embraced under that interval, then we are simply saying that the x value or the random variable x is continuous. Now, the difference between discrete and continuous is that x here is just taking up all the values under a certain given interval. But when it comes to discrete only focuses on counting numbers, does not focus on fractions. These are decimal fractions. But when it comes to discrete case with mathematically, we're just talking about integer values, countable numbers. Continuous here, we're just talking about it being continuous, embracing all given values depending on that interval. For example, you can talk about the weight of students taking statistics class. So talking about, if I look at your weight, or maybe the weight of your class, or maybe a sort class. So what are the weight of all the students there? So you find that there are people, when I look at the weight, there are people who are weighing maybe 40.2 kgs. There are people who are weighing 40.3. There are people who are weighing maybe 50.1. So all these can be regarded to be in a continuous case. They are all falling under a certain interval. Maybe if I look at all the class, you discover that all your values maybe might be falling from 30 kg to somewhere maybe 68 kgs. Maybe there's no one who is going above 70 kgs. So this is the interval we're talking about. So the continuous variable x can take up values from 30 to 68. So this will be more like our range or our interval notation. So x there will be taking up all the values between 30 and 68. So this is an example. Maybe if I'm talking about the weights, or maybe if I was to talk about the heights, or maybe if I was to talk about the length of time between arrivals of you students in class. Maybe if I was to talk about you are having a class at 18 hours, what is the length of time you're going to be arriving? There will be people who will be arriving at 18 hours sharp. There will be people who will be arriving maybe at 18:01. There will be people who will be arriving at 18:03. There will be people who will be arriving at 18:30. So you discover that for everyone to come, there's a certain range of time, which means most of the time for me to have every one of you coming in class. So the range of time people would come maybe is between 18 hours up to 18:30. So the interval we're talking about here can be 18 less than x, and the x is less than 18:30 hours. So this is more like a range. The values in between here will take up the x variable, which is continuous. It can be 18:01, 18:02, 18:03, way up to 18:30. That's why we're simply saying that this, in this case, is basically something which is basically continuous case. So this is what we talk about, what we mean when we simply say a random variable can be continuous, or a random variable can be discrete.